Welcome to spend your time with me. I know there's a full auditorium for Maarten Smit, which is kind of the, 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 the thing that always happens at Tech Days. So I'm really happy to see some people even coming in, so thank you for that. Um, this talk is Mastering the Debugger in Rider. I know the program said something about a level 300. It's actually going to be more level 200s. But what I want to do is give you an overview of the debugger functionalities in Rider. Um, It's not going to be about hardcore debugging with symbols and looking into things that WinDBG could do, for example. No, just a day-to-day routine and the tips and tricks that you can learn around debugging using this tool. So just before we start, is any one of you using Rider on a day-to-day basis? Okay, awesome, thank you. So you probably know already a couple of these things, but again, I hope you step out with a couple of learnings that you can take away. I'll skip that. Just to introduce you to debugging. So debugging, if you look up the definition, if you look up any blog post you want to find, you will see that debugging is always described as the process of finding and resolving defects in code. That sounds kind of vague and so on. So let's illustrate what debugging is. So typically, 90% of coding is debugging, and the other 10% is writing bugs. I think a lot of you will laugh, but I feel it's reality most of the time. Another one, if you code for 6 minutes, you will be debugging for 6 hours. That's typically something that always happens in someone's career. And you probably also know this one, the 6 stages of debugging, where you first go, okay, that can't happen. And in the end, you go like, how could this have ever worked? If you search the internet for memes around debugging, you will find tons of these things, really funny ones. But I think the bottom line of whatever is happening here is that we cannot work around having to debug our codes. Everything we do every day is probably going to revolve somewhere around debugging your codes. So no code is bug-free. That's what you will see in all these memes and in all blog posts and lots of talks out there. And most people will dive into WinDBG and go like hardcore debugging with symbols and figuring out whatever happens. But I think since 90% of our coding is actually debugging and 10% is writing codes, I think we have to learn about the tools that are at our disposal in Visual Studio, in Rider, in code, or whatever. We are just bad at writing business logic. And we need something in this tool to help us improve on that business logic, make the business logic work better. And if something really breaks on the technical side, not the business logic side, we can still use tools like WinDBG and really the hardcore debugging. So debugging in this presentation is going to be more about understanding logic, understanding what is happening in your code, and understanding what kind of business system you're actually building and figuring out how things work together, how one piece of data can influence another, etc. With that, I know a couple of you are using Rider already. If not, Rider is a new IDE on the block. It's a full-featured cross-platform .NET IDE, works on Windows, Mac, and Linux. You can open any .NET project, any .NET solution that you currently may have. Just open it, start working with it, write C#, VB.NET, F#, whatever you want to do. Also on the client side, JavaScript, TypeScript, CSS, and anything you have there. The thing we want to do with Rider is being lightweight, really fast, and compatible with everything else that already exists on the market. But we want to make you more productive in writing code, debugging code, and inspecting codes, or in the light of this talk, make you more efficient at writing bugs and debugging bugs. Rider's debugger, if you look at it, there's a couple of things that are in there. One is flow control, stepping into, stepping over, stepping out, and so on. So all the things that you probably expect from a debugger. And also inspecting variables, seeing what is in memory, what happens after I execute this line of code, and so on. Rider has the concept of run configurations. I'll dive into those as well, where you can say, okay, Rider, I want to debug one application. I want to debug my front end and my back end at the same time. 2 .NET projects, maybe a JavaScript project and a .NET project at the same time in one debugger. Several breakpoint types. Some are available in other IDs as well. Some are kind of unique in Rider. And then we'll dive into parallel debugging. So with that, I think I'm through my slides and we can skip to some demos. So I have a very simple program that I will be using throughout a lot of this talk. This program, what it does is I have a JSON file that contains some people with a name, an email, a company, which is an embedded object with a name and so on. And in my program, I will just load this JSON, make it into an object model, and then print those out to the console. So a really easy program, but just to show you how you can step through this code and work with all the different breakpoints that are available. So probably, I hope everyone is past the stage of just writing console.writeLine or something like that to do their debugging. I really hope that is the case. And everyone knows about setting a breakpoint. So again, in Rider also this works. You set a breakpoint, you start debugging, and once the application starts, we end up at this breakpoint, the application execution pauses, and we can see whatever is in memory. A couple of things. I can see the line that is being executed in yellow. I can step over using a shortcut and step to the next line of code and execute these lines one by one. And what you will see in Rider is that in the editor, we actually show you the value of all the variables that are available in the current context. So in this method, in my main method, I have my arguments that I can see in line. I have my JSON that I loaded in line. And I can just concentrate on reading my code and seeing the values that are in there without having to dive into a tool window to get more information. Of course, I can dive into a tool window to get more information, and you will see that all the variables that I have in memory in my current context are in there. I see my arguments to my program. I can see my JSON has been loaded. The debugger already deduced that I will have a people dictionary that I will be populating, and if I execute this line of code, you will see that my people has been loaded, and I can see the counts. And in my debugger window, I can see the people that are in there. I can expand these variables, etc. Now, for those of you who were in my talk yesterday, you have learned that in Rider, everything is searchable. Every tool window is searchable. So also in here, I can search through my list that I have in there. So if I search for example, company JetBrains, I will find the first item that contains JetBrains as a string, which is my string of JSON. Can be useful, cannot be useful, but by using some debugger features, you can actually make this search kind of powerful as well. So let's do that, and let's maybe dive into something else. So I'm loading my objects into this person, and what I can do is make use of the .NET debugger display attribute on that. And what this does is it gives the debugger a hint on the data that I want to show in my debugger tool window and inline in my editor. So what I can do is say, okay, if you want to debug the person and if you render it into this list, just show the name and the email. Nice thing is that we have completion here, so if you just want to use the name, you can use completion to complete the name and so on. But this will, if I debug now, display the name of the person and the email of the person. Nice thing is, if I now debug my code, you will see that if I load my objects, the people will be in here, and they will now show the name and the email in the list here. And the cool thing is, if I now use this search functionality, I can actually find a specific element in my collection. It's not super advanced, like I cannot search into child objects and so on, only in the in the objects that are actually expanded in this tool window. But it's still kind of useful to just search for whatever is in there and be able to find those things. Yes? Just start typing. There's no shortcut to start searching, just start typing. Same in other tool windows. If you have the Solution Explorer active, for example, you just search, for example, for company. It will highlight company, just start typing, and you have those things. Right.
Will it work the same way if you override toString? Because in Visual Studio Debugger, you usually...
If you override toString, it will work as well.
Also can search it.
Yeah, exactly. What else is in there? Okay, we've seen that we can start the debugger, that we can break and so on. We can also step over or step into a specific method. So right now I'm on this print people where I execute the link statement and there's a lambda in there. If I now step into using F11, you will see that I actually step into the link lambda. So I can also debug that one. Also, if I want to place a breakpoint on this statement, if I would place a breakpoint, Rider will actually ask me, do you want to place the breakpoint on the entire line of codes, on the statement that prints the people, or just on the lambda that you are trying to execute? So it helps you in stepping into the things that you are really interested in and not having to F11 into what you actually want to see there. Right, so let's step over that one and then step into our print people. Again, here we see the variables that are being executed and evaluated. We can see whatever is happening in there, and we can start stepping through our loop. We can see the person, which now also prints the name and the email address nicely in the editor. And we can step over and we can go to our next iteration and so on. And at a given moment, I find a potential bug and I want to investigate again. I want to run this loop again. I see a lot of developers actually stopping the debugger, restarting the debugger and trying to go to the same state again. There's a couple of things you can do here. If you have a for loop, for example, what I could do is set the value of I to 0 again, and I can restart my iteration over the I. So what I can do is from the variables window here, I can say, okay, set value, and I want to make I 0, and it will execute the loop again from 0. Now this is if you have a nice for loop where you can actually set the index of the element you want to execute. Another thing that you can do is just say, okay, right click, set next statement, and you can tell the debugger to rewind part of its execution stack and restart the execution from the start of my print people method that I have here. So if I now run through it, it will iterate all the same persons over and over again. Yes?
I have one question about going back to the stack. Does it also undo any operations done on the objects?
No. So if you do any operations in the loop on the objects, you change the data, you will just re-execute the code, but the state of the objects that you have in memory will be the same state after the first execution of that code. So it's not historical changes that you can make. Some other things that we can do. In the variables tool window here, we can see all the variables that are in scope, but maybe I want to just show the current company or the current person or the name of the current company. So what I can do is add a watch there. So let's add a watch for company.country, and you see you get nice code completion, and I can look at the country of the current person that I'm printing to the console. So that's one thing. I can also do things like adding lambdas in there. So if I want to print the first person of my people collection here, what I could do is say, okay, I'm interested in people 0. It will print that one. Or I can add a watch that says, okay, give me people.first or default where the person.company.country equals Czech Republic. And then I will see that one as well. So I can add lambdas into these watches too. Yes?
Is it limited compared to the normal execution? Because, for example, in Visual Studio, if you have a really big enumerable, it can be executed normally, but when you try to add it as a variable and do some lambda on it, it usually just refuses to do anything as that it's too big.
It depends on the size of the collection a bit. I haven't tried it on really big collections, but usually on smaller ones it just works okay and just renders. The only thing that you have is if you do this on an IEnumerable or an iQueryable, you're obviously evaluating the code that is sitting behind, so you may be doing database queries and so on. All right, what else do we have here? We can mark objects. So imagine when I start my application, and let's maybe restart the debugger here for a while, for a minute. If I'm loading my people, and I'm interested in seeing where I am using a specific person's company, what I can do is for that person mark the object that is in, for example, this company sub-property of my objects. So what I can do is mark this object. I can give it a name saying potential bug, maybe. And I can change the color of this and make it green, for example. And what will happen is if I add this in the debugger, I will see that this object is now marked with a label that I decided on and a color that I decided on. Now, if I step into my code, let's go back to this statement here. If I step into this thing, what will happen is if at some point in the execution flow, I have this same company that I marked, I will immediately see in the debugger that I now have this potential objects that I marked in an earlier iteration or in a different place of my code. It's actually just checking the object ID in the debugger and making sure that this object ID always displays with whatever properties you added to it. Yeah. You cannot drag drop the next statement, so it's always using either the mouse or just using the keyboard shortcut, I think Control Shift Alt F10.
Is it supposed to be editable? Because, for example, Visual Studio is supposed to drag drop.
Yeah, it's in Rider you cannot drag and drop it. It's just setting the execution pointer. The movement is different, but the functionality is very similar. Yeah. One other thing that I could do is use run to cursor. So for example, I can say, okay, I have some breakpoints in here, but I'm not really interested in them. What I can say is, okay, just Rider, go to this location, run to cursor, and the breakpoints will still happen. But I can also say force run to cursor, and it will just skip all the breakpoints that are in between and just move to this specific statement that I'm interested in, actually. Right, so I think that's more or less the basics of how the debugger works. Of course, a couple of other things that you may have seen. We have on the left of the debugger tool window, we have the stack traces, so you can jump back to our main, for example, and immediately you can see all the variables that were in scope in this part of our call stack. Or we can go back to our print people and so on. Nice thing is, and I will cover that a bit later, if you have multiple threads, you can do this per thread as well. So you can go to a specific point of execution for a specific thread as well in this tool window. Right, for those of you who have been using Rider, you know, if you open a project, you just press F5 and it will give you this small pop-up to confirm what you actually want to run, and it will run or debug. That concept is called a run configuration. So in Rider, instead of just having either one startup project or multiple startup projects, you can decide on many run configurations. So in this application, I only have one, but let's switch to another one where I have two. I have a front end and a back end. So I created two run configurations, one for one project, one for the other. And by just selecting the project that I want to run, I can run this specific project, which makes it easy to switch between the things that you want to run. A nice addition there is that you can also create a compound run configuration where you just say, okay, I want to run both my front end and my back end. And again, I can switch to this specific configuration from the toolbar here and say, okay, I want to run my full stack, my front end and my back end, and I can debug into that as well. So it makes it easy to switch between what you actually want to debug and run. Right, a couple of other things that are in here that are kind of interesting is that for every run configuration I can add additional options. So as you can see, this one I can just select the project that I want to run, I can select the target framework, I can set executable that I want to run, in this case IIS. But I can also specify environment variables. So this could be easy if you have some secrets that you don't want in a config file because you don't want to accidentally check them into source control, for example. What I can do is for every application that I want to run, I can add environment variables to test something. So if you're building Windows services or something and you want to add something in the environment, you can do so specifically for this run configuration. Another really nice thing that we have there is that for every run configuration, you can also do like a pre-run configuration. Before launching the debugger or before launching the application, execute some specific action. What I can do here is say, okay, obviously I want to build my project before I run, so that's a default that we have there. But what I can also do is say, okay, run an external tool, just any random executable. I don't know if anyone is doing Azure development, for example. I typically have for some applications starting the Azure Storage Emulator in one of these before launch tasks. One other that you may have is if you have a web front-end application and you're making use of gulp or grunt or whatever, what you can do is say, okay, I want to run a gulp task before my application starts. I can select my gulp file that will be detected from my projects. I will see all the different tasks in there and say maybe, okay, run the default task before you actually start this application or start debugging this application. We have the .NET run configurations and debug configurations, but we also have them for other project types. So if you want to run a Node.js server and you want to run a .NET client against it, you can also create a Node.js run configuration that just starts a Node.js based server, for example, or runs some specific Node.js script. Let's quickly close these, because the next thing I want to show you is actually not yet in the released product, so I want to open a nightly version of Rider. That's always dangerous during a talk, and yeah, we'll see what happens. You may see some exceptions popping up and so on, but please ignore them and think it's a stable version. Right, let's open NancyFX. So NancyFX, I don't know if you know it, it's an open source REST framework where you can build web applications, web APIs and so on. It's a nice project because they have lots of projects. and lots of things that you can actually show in those projects. So another thing that you can debug, and this is already in the stable version, another thing that you can debug are unit tests. So what I can do is, of course, put a breakpoint somewhere in a unit test and say, okay, this unit test, I want to debug it. The application will be compiled and the debugger will attach to this to the unit test runner, and I can debug into my unit test. So as you can see, I now have the debugger in my unit tests. What does Samuel L. Jackson think? Awesome. I can step through this, I can do all the things that I showed you earlier, but the nice thing is I can debug my unit tests. Now, another nice addition that we have there is that if we do this, the unit test is also added as a temporary run configuration. So if I'm working on a specific set of unit tests, I probably want to repeat the action of debugging, fixing it something, debugging it again, fixing something, debugging it again. What we do is we create a temporary run configuration where instead of having to find out where the unit test is and debug it again, you can just say, okay, I want to switch to this debug, to this specific unit test to debug, and just start the debugger on that. Yes?
The whole unit test is added to the configuration of the unit test, for example, with specific set of parameters, if I have multiple.
It depends. So in this case, I just ran one unit test that I wanted to debug, but I can also debug my entire test.
No, but if, for example, if for a single unit test, I have several test clauses with different input parameters, so
Yeah,
test
yeah, like inline data in XUnit, for example. It depends. It will show the. I don't think I have one.
we'll show them in the session that I know, but will it add the
It will add the temporary target, but it will be for the entire unit test and not just for one specific data entry. Yeah. So debugging unit tests, that works fine. Other things that you can debug are front ends. Rider is actually WebStorm, our front-end development IDE that has excellent JavaScript support and so on. So what you can do is also debug the front ends. Nice thing is, if I have an application like this blog application, what I can do is simultaneously debug my JavaScript frontend and my .NET backend, and this is why I need it nightly. So what I can do is say, okay, open the browser after launching my application and attach to the JavaScript debugger. I can say, okay, I want to run the root of my project, this port. Again, I can select to run gulp or grunt or whatever, and say, okay, let's start the debugger. The nice thing is that Rider will start my backend, my C# backend, also launch the browser, and you will see we actually have a plugin for Chrome, where the plugin connects to Rider and gives me the debugging information. So instead of having to use the F12 tools in Chrome, I now have the F12 tools from Chrome within Rider. So I have my JavaScript that I'm debugging, I can step over, step into, and so on, and I can see the call stack of my application. In JavaScript, you can see the console, can see the scripts that are loaded, and look whatever is in there. I can evaluate variables, I can set values to variables, and so on. So everything you expect from the debugger, but just it's the Chrome debugger integrated into Rider.
Other browsers?
It does not work in other browsers, so we only have the plugin currently for Chrome. Yes? The plugin has existed for a while. The fact that we're lighting this up is the early access part. So we're lighting up this functionality in Rider currently. Just the debugger part, yeah. So it's not the entire Chrome debugger tools, but just the JavaScript debugger. The nice thing is, if I do, for example, JSON call to my backend, if I run through this, I will jump to my C# client application, and I can immediately continue debugging on that side and look into the variables in my current backend project that I have and so on. So that's really nice. Of course, an AJAX call has to return at some point. So if I continue debugging, I jump back to my JavaScript and I can continue to work there. So without having to open two debuggers and switch contexts and so on, I can just work my way through the flow and follow the entire flow that I want to do in there. Any questions? Yeah. This also works in PHP Storm, yes. So for those of you who don't know, Rider is IntelliJ as the front-end or IntelliJ platform, and that is shared between all of our other IDEs, PHP Storm, WebStorm, PyCharm, and so on. So this thing is actually in PHP Storm already. Yeah. It depends, because I'm using jQuery here, so what will happen is I will jump to some minified version of JSON because I don't have the source maps on my system. If you do have the source maps, you will actually jump into the Chrome full source code, or the jQuery full source codes. Yeah. Right, let's close this one, and just for safety, let's return to a stable version of Rider now. Because I've been bitten by this in a talk yesterday, so not going there again. Right, let's go back to our simple application to show you the different types of breakpoints that are available. Right, so we've seen a simple breakpoint where the application pauses execution at a certain point in time. We can also do other things that you would expect the debugger would do. So I can say, okay, I want to pause on print people, and I want to make this a conditional breakpoint. I can say, okay, only if people dot counts is larger than 0, I want to break here. If the people that I loaded from the JSON file is null or empty or whatever, I will never pause at this specific breakpoint that we have there. So what you would expect from a debugger. Sorry? If it throws an exception, then it will throw an exception. Yeah, you will see the exception popping up. Now, the nice thing is that instead of just adding the condition here, I can do some nice other things with these breakpoints as well. So let's see if we can do something else. I want to make sure that actually people are being loaded, but I'm not interested at pausing here in the application. I just want to verify that actually data was loaded from disk. So what I can do is, instead of suspending, instead of pausing the application, instead of pausing the debugger when I hit this breakpoint, I want to do something like logging a message to console. Whenever I run this, the debugger will print something to the console saying, okay, you've been at print people. So now I skipped the print people breakpoint, but in my console, we should see, but we don't. We should see that we actually passed here at this print people. Another bug to log today. Awesome. Now, what Rider should actually be printing here is something we passed the breakpoint at line 50 of program.cs or something like that. That's not so interesting. So what I, yes?
It wasn't already past the line, so maybe that's why it didn't.
Yeah, I just restarted it again.
Yeah, right. That's the thing. Thanks. Nope.
No, it's still in there, right? So it's in the line that you highlighted.
No, no. Let's ignore this for now. Imagine it works. The thing it will print to console though is something like, okay, you passed this breakpoint on this line of this specific file, and if you're debugging and your mind is really set to a specific thing you have in code, it's really hard to figure out what does program CS line 19 even mean. So what you can do is, instead of just logging, you can evaluate and log and say, okay, people loaded, add something meaningful like a string, or even add something like people.count to this string, so you can actually see that people were actually loaded on the console.
But when you start typing people, will you have like highlighted which object you have and which properties of object people you have?
Yeah. So
As in column, yeah.
as you can see, you see the auto-completion here, so I get the count, and if I want to go into the first person in there and go to the company, I can do all those things as well, yeah. So just to make sure, let's maybe try this one and see if we get the number of people logged to console. No, we don't.
We put a number
Here it is, but it's not evaluated. Anyway, again, let's imagine this works. Man, I have a bad day. So I can log to console. Some other things that I can do is make the breakpoint conditional. We've seen that. Other things we can do is add a hit count to a breakpoint. So imagine we are loading 20,000 people, and we get some stack traces from production where somewhere around item 10,000 something breaks, and we want to debug item 10,000 in our lists. Couple of things we can do. Of course, we can debug in here and set I to 10,000 and just start from there. Another thing we can do is say, okay, I'm interested in person, but I want to add a hit count to this and say, okay, only when this breakpoint has been hit more than 10,000 times, I want to pause the execution of the program here. So let's say, since I only have 4 items in there, let's say if it's greater than 2, what will happen is my 2 items will be skipped, and I will immediately land on my third item. So as you can see, I equals 2, which makes it easier to debug those large typical collections or database result sets and so on. Right, what else is in there? Another nice one is, okay, we have the hit counts. Another nice one is that we can make temporary breakpoints. So let's say I'm interested to see this breakpoint being hit, and the first time it's being hit I want to inspect whatever is in memory, but the second time, the third time, and all the times after that I'm not interested into it. You can make it a temporary breakpoint by removing it once hit. And what will happen is, per debugging session you start, the breakpoint will only hit once, and after that it will never show up again until you restart the debugger and you get that information again. I should have stayed in this tool window. Another breakpoint type that we can add is dependent breakpoints. So imagine you have a backend process or a message loop or whatever that just fires every couple of milliseconds and keeps looping, keeps looping, keeps looping. And I'm interested to add a breakpoint in there because I want to know what happens in this message pump that I have in my application, for example. But I only want to know this once a specific menu entry was clicked. Of course, you can add conditional breakpoints and add a variable to your application and check the variable to see if you should pause. But the other thing you can do is just add 2 breakpoints. So let's uncomment this one. And I have a second method that also prints the people. And eventually it will come back to my print person method that I have here. If I would run this, I would actually have this breakpoint hit 8 times. Why? Because this one hits it 4 times and this one will hit it 4 times. What I want to do is make it so that I'm only breaking the application when this first thing has executed. So what I can do is add a breakpoint here on my print people. And for this breakpoint, we can say, okay, make it a dependent breakpoint, where the dependency is this other breakpoint. The nice thing is, if we now start the debugger, when we will pause this thing, I should have made this a non-suspending breakpoint, by the way, but you see print people already executed and I did not break in this print person method that we had. So I will now only get 4 times that it will hit because of the second loop we have there and the dependent breakpoints. Now this takes 10 seconds. Why? Because I added a thread.sleep in there for 10 seconds. But you see it ends up in there eventually. Right, other things we have. Of course, we have regular breakpoints on your own code and so on, but maybe you're also interested in having breakpoints for a specific exception. So what you can do is you can add a .NET exception breakpoint, and by default, Rider will break on any exception. Now, these also have the options that you can suspend or not suspend the application, and maybe if you're not interested in suspending on an exception, but you do want to log to console, you can do so, or log some properties of the exception instead of breaking the application and breaking your debugging flow. What I can also do is add a .NET exception breakpoint for a specific exception. So let's say I want to break on a file not found exception. I can search for it and say, okay, on file not found, if that exception happens in my application, pause the application and do something with the debugger there. Note that this works for .NET as well as JavaScript. So you can add JavaScript breakpoints, you can do dependent breakpoints in JavaScript and so on as well. Yes? That's a tougher one because you would have to add all the different exception types for system.io in there. But it's a good feature request, so I'll try to remember. Thank you. So we have that for .NET as well as for JavaScript. Now, these are all the visible things that are in the tool window for my breakpoints. There's a couple of options in Rider that we can enable as well. So let's go to the settings and find our debugger. You can again search everything we have in there. So go to debugger. There's a couple of things we can configure in here. So for .NET, your question about evaluating large link statements and so on, what you can do is say, okay, I do not want to evaluate those. If you really have these big collections and you hover something by accident and your debugger hangs for half a minute, you can disable this behavior if you want. You can add a timeout there as well. If it takes longer than 1 second, it will stop. If you have something that you know will take 20 seconds and you're okay with that, make it 25 seconds and you will have a larger timeout in there. Some other debugger options are disabling just-in-time optimizations or maybe breaking on user-handled exceptions that you have in there. One that I actually like is that you can also change the behavior of removing a breakpoint. So imagine you have this complex setup of dependent breakpoints and so on, and by accident, somewhere in the code you press F9 so the breakpoint is removed, or you click it by accident because I actually wanted to click on this one and I'm stupid and I clicked on the breakpoint icon. If you have something like that and you want to avoid messing up your debugger configuration, you can configure the debugger to only remove breakpoints when you drag them to the editor. So now, if I click my breakpoints, it will not be removed. It will be disabled for a while, but it will be removed and the configuration will stay. And only if I grab it and drag it to the editor, it will be removed. Minor thing to basically make sure that all your hard work of configuring the debugger is not lost. Sorry? F9 will not work in this case, so you really have to drag it to the editor. All right, what else do we have? Parallel debugging. So as you've seen, I have two methods here, one that just prints people and one that prints people in parallel. Let's maybe dive into the code for a second. This one takes the same collection of people and it will very unoptimizedly start several threads. And in those threads, wait for 10 seconds and then call into my print person to actually print the person to console. Then it starts the threads and at the end it joins the threads. Now, I did one thing to make the demo a little bit more visual, is I named the threads that I have in my application to the person name. So in the debugger I will actually see thread names instead of stupid integers. So let's run this and put a breakpoint on print person here. And start the debugger. So the first time, I forgot to make a dependent breakpoint, so the first time I'll step through them because it's the non-threaded version. Second time I have my timeout of 10 seconds, and at a given moment, within 10 seconds, we should see the debugger break here. There we are. The nice thing is, I told you about threads. What I see in the debugger tool window is all those different threads are listed here. So I can see all the different threads. Remember, I named them to the person that I was debugging. So I can skip into the call stack for a specific thread or into the evaluation stack for a specific thread and see all the different items that are in there. So it's kind of nice to switch between threads and see what's happening in one versus the other. This is one view. We have another view where you can see the threads and you can just open them up and you see the stack trace and the variables in there and so on. Now, one other we have here is the parallel stacks that you can see. So you can see that in this application, let's make it a little bit bigger, we have 4 threads that originated from program.printPerson, and those 4 threads are listed here. And the one that I'm currently breaking in is highlighted as this specific thread that I'm now in. I can see these 4 threads all seem to execute printPerson, so I can see this as well. So I can visualize what all my different threads are doing at a certain point in time. And I can even, if I do stepping, not in this example because it's too simple, but typically you will see the threads evolve, spin up new threads, remove threads, and so on. So I can see what is happening in my application. I can see that right now my current thread is Hadi Hariri, so one of the people that I have in there. But I have at the same time still one other thread running, which is the one that I'm apparently in. So I can see all these things and see what's happening, and probably this thread is currently paused as well. So if we step, you will see that all of this changes and the diagram changes to whatever we are currently executing and whatever threads are still active at this point in time. Any questions on that? All right, cool. Then I think I can show you the rest of my slides, which is, yeah. It will keep jumping between the threads, yeah. Right now there is no way, I think, no. Again, good feature request. Thank you. Good. You could make a conditional breakpoint with some variable, yeah, but then again it's manual work that you have to do and change your code to actually help your debugger out. In summary for this talk, thank you for being here again. If you want to try out Rider, all the things that you expect are in there. Flow control, where you pause, resume, step over, step into, step out, set the next execution point, and so on. We have this concept of run configurations, where you can create one, can create multiple, start two parts of your application at the same time, do front-end and back-end debugging at the same time, and so on. So those are in there. We have the different breakpoint types that you would expect, a regular breakpoint, conditional breakpoint, and so on, but also things like these dependent breakpoints that can really help you build a flow in the debugger that makes it easier to debug the more complex cases in your business logic. And then we have parallel debugging, where you just came up with a really good suggestion to sticking to just one thread and not showing the other threads. But then still, we show you all the different threads, all the call stacks that are in there. You can dive into whatever is somewhere in the context of that thread and see what's going on in your codes. With that, I think we're right on time for lunchtime, and there's one more question. Accidental removal is not in the slide, but I did mention it, where you had to drag to the editor to remove the breakpoint. Yeah. So with that, I think it's lunchtime. Thanks. And if you are interested in Rider and trying it out, Matthias back there has some vouchers to try it out. Thank you.